Road to Olympiad.
Welcome to RTO. Consider the following problem. Find the smallest positive integer a for which the equation below has real root. Today is March 14, Pi Day. Hope everybody enjoy your Pi Day. And here today we have a problem involving pi. Hope everybody will like it. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, first we notice that we can rewrite the equations like this, which the left part of the equations can be simplified into this one. Now notice that the bracket on the left is a perfect square, and thus it must be non-negative. For the expression in the right bracket, we notice that the product of two cosines must be at least -1. Therefore, the product of two cosine plus 1 must be non-negative as well. Therefore, in order for the equation to have solutions or real roots, we need both the expression in the bracket to be 0. So we are trying to solve the equation for the case where both the expression is equal to 0. For cosine pi a minus x minus 1 is equal to 0, we have cosine pi a minus x is equal to 1. This tells us that pi a minus x is equal to 2kx for some integer k. Dividing the pi and moving the x to the other side, we have a is equal to 2k plus x. We'll keep this equation for later use. For the second expression to be equal to 0, we have cosine 3 pi x over 2a multiplied by cosine pi x over 2a plus pi over 3 is -1. Since the absolute value of cosine is less than 1, in order for this expression to be equal to -1, we must have one of them is equal to 1 and the other one is -1. Therefore, we have two cases. Cosine 3 pi x over 2a is equal to 1 and cosine pi x over 2a plus pi over 3 is equal to -1, or cosine 3 pi x over 2a is equal to -1 and cosine pi x over 2a plus pi over 3 is 1. For the first case, when cosine pi x over 2a plus pi over 3 is -1, we have pi x over 2a plus pi over 3 is equal to 2m plus 1, the whole thing multiplied by pi, for some integer m. Multiply the entire equation by 6a over pi, we have 3x plus 2a is equal to 12am plus 12a, which can be simplified into 3x is equal to 12am plus 10a. For the second case, when cosine pi x over 2a plus pi over 3 is equal to 1, we have pi x over 2a plus pi over 3 is equal to 2m pi for some integer n. Similar like just now, multiplying 6a over pi on both sides of the equation give us 3x plus 2a is equal to 12an. For both cases, we have a is a multiple of 3. To explain, for the first case, we can rearrange the equation and get 10a is equal to 12am minus 3x, which can be written as 3 times 4am minus x. This tells us 10a is a multiple of 3, but 10 is not a multiple of 3, therefore it must be the case that a is a multiple of 3. Similarly, for the second case, we can rewrite the equation as 2a is equal to 12am minus 3x, or 3 times 4am minus x. Again, 2a is a multiple of 3, which implies that a is a multiple of 3. So, for both the cases, we have a is a multiple of 3. Now, for both the cases, we are going to claim that x is an even number. This can be shown pretty easily for the first case, because 3x can be written as 2 times 6am plus 5a, which tells us that 3x is an even number, but since 3 is odd, it must be the case that x is an even number. For the second case, we have 3x is equal to 12am minus 2a, which is 2 times 6am minus a. Similarly, 3x is an even number, which implies that x is an even number. So for both the case, x is an even number, which tells us that we can write x is equal to 2p for some integer p. Substituting x is equal to 2p into a is equal to 2k plus x, we have a is equal to 2k plus 2p, or a is equal to 2 in the bracket k plus p. This tells us that a is also a multiple of 2. Combining both conditions, we have a is a multiple of 6. Knowing that a is a multiple of 6, we can easily find out that the smallest positive integer a must be 6. However, to show that this makes the equation have real roots, we still need to show the existence of the root x. As long as we can find that, we are done. In fact, we can have x is equal to 8. When x is equal to 8, we have the expression as follows, which is equal to 1 minus 2 minus 1 plus 2. And this is indeed equal to 0. So the smallest positive integer a is equal to 6. And this marks the end of our solutions. Post in the comment below if you have any thought on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you, and happy Pi Day.